Hey everyone, and welcome. Today, we are going to unlock one of the most powerful tools for telling stories with numbers, the line graph. If you've ever wanted to see how something changes over time, like, say, the stock market, or population growth, or even something like a patient's temperature, then you are in exactly the right place. So, let's jump right in.
So, here's our game plan for this explainer. We're going to start with the basics. What exactly is a line graph? Then, we'll walk through how you actually build one from a set of data. After that, we'll get some practice reading the trends and even solve a few real-world problems. And then, we'll wrap it all up with the big takeaway. Trust me, by the end of this, you'll be all set.
All right, first things first. Before we can really use a tool, we've got to understand it, right? So let's get a really solid handle on what a line graph is and why it's such a fantastic way to visualize data.
Okay, so at its heart, a line graph just tells a story about change over time. Think of it like a game of connect the dots. You take your data, plot each point on a grid, and then you just connect them with the line. That simple line tells you a really powerful story, and you can get it in a single glance.
So you might be asking, why even bother? Well, there are two huge reasons. First, you can instantly see the trend. You can see if something's going up, if it's going down, or if it's just staying flat. And second, and this is the really cool part, you can often use that trend to make a pretty good guess, a forecast, about what might happen next.
All right, that's enough theory. Let's get our hands dirty, shall we? Let's see how we can take a boring old table of numbers and turn it into something visual, something that's actually easy to understand.
Here's what we're working with. The population of Singapore, measured every 10 years from 1970 all the way to 2010. Now, just by looking at the numbers, you can tell it's growing. But it's kind of hard to get a real feel for that growth, isn't it? It's just a list of numbers.
Now check this out. It's the exact same data, but what a difference, right? Each one of those dots on the graph matches a year and a population number from our table. By just connecting them, boom, we've created a story. This just shows you the incredible power of making data visual.
So, what's the story this graph is telling us? Well, we can clearly see a steady increase over those decades. But look closer. See how the line gets steeper between 2000 and 2010? That's the key insight. It tells us that the growth didn't just continue, it actually accelerated. You can literally see the pace of change picking up.
Great. So we know how to turn data into a graph. Now the next skill is getting really good at reading what that graph is telling you. How to pull out specific facts and figures from that visual story.
Let's look at a new example. This one tracks the Singapore Stock Market Index over 5 days. The horizontal line at the bottom, the axis, that's our time, in days. And the vertical one is the value of the index. Just by glancing at it, you can tell the market had a bit of a bumpy ride that week.
Okay, time for a little test. Take a good look at that graph. Between July 5th and July 8th, on which day did the index have its biggest single-day jump? Here's a hint. The answer is in the steepness of the line.
Let's break it down together. To see how much it rose on July 7th, we just subtract the previous day's value. So 3126 minus 3115, that gives us 11 points. Now let's do the same thing for July 8th. 3151 minus 3126 gives us a much bigger jump of 25 points.
And there it is. The biggest rise was 25 points on July 8th. And just like we thought, that's where the line on the graph was the steepest. Remember that, because it's a key takeaway. A steeper upward line always means a faster increase.
Okay, class, pop quiz time. Let's see how we can use these line graphs not just to look at data, but to answer some really important real-world questions.
First one up is a medical chart. We're tracking a patient's temperature all day. So your job is to find the peak of the fever. What was the highest temperature recorded, and what time did that happen?
See how easy that was? It's really as simple as finding the highest point on the line. The peak of the graph is right there. We look over to the side, it's 40 degrees Celsius, and we look down, it's 9 p.m. It's simple, it's clear, and that is absolutely vital information.
Okay, now for a more serious question. This graph shows someone's blood alcohol concentration, or BAC, over time. Now, let's say the legal limit to drive is 0.05%. Looking at this graph, how long does Jack need to wait before he can legally get behind the wheel? This is where reading a graph is about a lot more than just numbers. It's about safety.
So here's how we figure this out. We find that 0.05% mark on the vertical axes, and we just draw a line in our minds straight across. You can see the BAC starts above it, it peaks, and then it starts to fall. What we need to find is the exact moment in time when that line drops below our 0.05% line.
And there we have it. If you follow the line down, you can see it finally dips below that legal limit right at the 2.5-hour mark. So Jack has to wait at least 2.5 hours. It's a perfect example of how a line graph can give us a crystal clear, actionable answer to a really important question.
Whew, we have covered a ton of ground. So, before we wrap this up, let's do a quick recap of the core skills you've just picked up, the essential steps for mastering any line graph that comes your way.
I want you to remember this simple 4-step process. First, you plot your data points. Second, you connect those points to reveal the line. Third, you analyze the trend. What's the story that line is telling you? And finally, you use that understanding to answer the question. So it's plot, connect, analyze, and answer. Easy.
And that's really it. You now have the fundamental tools to not only read line graphs, but to actually start seeing the stories hidden in the data that's all around us. So my final question to you is this: what story is waiting for you to uncover next?